Here's an interesting subject. What must an open loop daylight harvesting system need to know for it to function properly? And when we say open loop, we're talking a straight open loop sensing system, not, for instance, a Lutron radio power saver partial open loop sensor or an LMLS600 by Watt stopper, unless it's set for just straight open loop operation. What we're talking about is basically looks out the window, adjusts the lights in the room, and let's take a look at the very first thing that it has to know before it can even start functioning in any real manner whatsoever. And this first thing is what amount of light is hitting the sensor or being reported by the system sensor when a certain amount of daylight, and daylight only, is being recorded in the interior of the space under control, and that is your sensor ratio. In other words, if I have a certain amount of light here, I'll have a certain amount of light getting to my reference location. This reading should ideally be higher than this reading, which you will be taking on your light meter. So you ask the sensor, what do you think you're seeing? And you tell it what you see on your light meter horizontal foot candles, which means with the pickup pointed straight up. Now the system is going to use that information, that ratio of amount of light it thinks it sees at its sensor versus the amount of light you're telling it is reaching your reference location, to develop a ratio so that when daylight comes in and hits that sensor, it's going to compute a daylight line at your reference location. So if the system needs to reduce, for some reason, dim down the electric lighting here 3 foot candles, and there's a 3:1 ratio between the sensor and the reference location, then when 9 foot candles, a change of 9 foot candles on this system sensor should cause a change of 3 foot candles at the reference location. This is the first thing you have to enter into an open loop sensing system to even get the thing started and off the ground. It will develop a sensor ratio. So you're going to need that reading, and you're going to need to tell it. Now, once it knows what to expect to see and hear for a certain amount of light hitting the sensor here, and we're talking daylight, we also need to tell it how much total electric lighting is under control of the sensor, not any other electric lighting that's coming into this area at your reference location, but just the controlled lighting, which would be up here under the control of the sensor. So if we see 30 foot candles of reference here and we have a 3:1 ratio, then the sensor will need to change 90 to dim the lighting, the electric lighting, down by 30 if we're doing a straight foot candle to foot candle reduction. In other words, if we're tracking at our design illuminance. So the system needs to know exactly how much electric lighting is under the control of this sensor. Now we could call this 2.5 or 3. Am I getting a lot of electric lighting impinging on the sensor? Because this is an open loop system and we just want it seeing a representation of daylight that's coming in the window and not any of the electric lighting that's under control. If this is a window, some of the electric lighting under control will bounce off of it, hit the sensor. I'm not going to say that this is something that you have to overtly state to the sensor, or even that the system is going to use this, look for it as part of its calibration. But I will tell you, if it's too much, you're going to drive your electric lighting off set point somewhat, or worst case, put the system into oscillation where the electric lighting goes up and down and up and down and up and down, and we'll see if we can force that in some of the open loop dimming contrivances that we put together out in the office. So this may not be a direct entry. In other words, you may not be directly entering how much deadband is required in the system, but it is an item of concern. And last but certainly not least is, how would you like your lighting today, sir and madam? How would you like the system to control the lights? Would you like it to immediately begin reducing electric lighting as daylight comes through the window, or would you care for an offset? Would you like a 1-to-1 reduction of the electric lighting, foot candle for foot candle of daylight seen here? Or would you like to change that response so that the electric lighting does not decrease the illuminance at the reference location on a 1-to-1 basis as sunlight comes in through the window? Maybe you would like to take some of the slope out of that response so that the electric lighting decreases more slowly as daylight comes in. This is all dependent on the sorts of settings you are allowed to put in the system, and it is your fourth thing, and it is dependent on at least the first two things being done properly if you are going to program anything but a direct foot candle to foot candle reduction. And so there you have it. Those are basically the four things that an open loop daylighting system needs to know, and in most cases you're going to have to tell it. See you next time.